Kingsa.com. Welcome to the lesson on stacks. In this first slide, we'll look at implementing a stack with an array. First off, a stack implements LIFO, or last in, first out. The last item placed into the stack is the first item that comes out of the stack. It's an extremely important data structure in computer science and game programming. Examples of stacks are the call stack, which tracks method calls. When a program starts running, let's say it starts running in the main method and it jumps to the run method, then it jumps to the menu method. It tracks the currently executing method on top of the stack, and it tracks how to get back when that method is done completed. Another example of the stack is what I call the undo stack. Let's say you're playing a card game and the card game has an undo button. So if you deal a card, you want to be able to undo it. If you deal 3 cards, you want to hit undo 3 times and undeal those 3 cards. Any card game, or any game for that matter, with an undo button would implement a stack to do that undo button. You see over here on the right the example of a stack where the last card dealt was the ace of spades. So if I hit the undo button, I expect the ace of spades to come off the stack and go back on the deck. The previous card to that was the 3 of diamonds. So if I hit the undo button again, I expect that card to be undealt. And finally, the first card being dealt was the Queen of Hearts. If I hit the undo button a 3rd time, I expect the Queen of Hearts to be undealt to the user. Any video game that has some sort of tracking code or some undo options uses a stack to keep track of those elements. Another example of a undo stack is the browser back button. We have all seen the browser back button go back to my previous web page. When you press it, your web browser goes back to the previous web page. Well, that's implemented using a stack. Over here on the right, we could see that my currently viewing web page on my web browser is youtube.com. If I hit the browser back button, I'll take YouTube off the stack and I'll return to my previous web page, yahoo.com. If I hit the browser back button again, I'll take yahoo.com off my back button and return to my previous web page, google.com. If I hit the back button again, it won't work because google.com is the initial web page that was displayed on the page. There you have it. There's our 3 applications of using a stack. Let's look at implementing a stack. Blocked out in the red box here is the class stack implemented with an array. An array always comes with that problem of what size should the array be. Now, if we were writing a playing card game like poker, blackjack, or go fish, where each card is a number 0 to 51, an undo stack would require a simple array of 52 integers. Since 52 cards in the deck is a small fixed size, an array is perfectly reasonable for implementing a stack for the back button of a card playing game. There are only 52 cards in the deck, so the stack will always be 52 or less. We'll trace this code when we build an actual stack. First thing I'd like to highlight though in this code is the variables. Right, the data portion of the stack. The max variable here is small. It's set to 5, so it'll fit on the screen. If this was an actual playing card game, it would be 52 because you could have as many as 52 cards dealt. Could also be a value past the constructor. I hard-coded this 5 for convenience, although I want to make sure that you don't assume that you'll always hard code a 5 here. Maybe you make it a parameter to the constructor and therefore the user gets to decide how big the stack will be. The next variable up here is the top, which is an extremely critical variable when implementing a stack with an array. Top is the index or subscript in the array of the last item placed in the stack. Therefore, it will also be the first item out of the stack, implementing LIFO. The third variable here is strarray. strarray will hold the value stored in the stack. If the number 11 represents the Queen of Clubs, an 11 will be placed in strarray when it is dealt. Methods. The red box here circles the methods of the stack class. These are the actions a stack object will perform. First up is a stack constructor, a constructor to initialize the variables. Maybe add a parameter for max. As I said, it might be useful to pass a parameter to this constructor and to determine the size of the max. It's always better when the user decides how big to make the array rather than the programmer hard coding it. Next, we have a push method. Push places a new item on top of the stack. We have a pop method. Pop removes and returns an item from the top of the stack. Push puts it on the stack. Pop takes it off the stack and returns it to the user. Finally, we have a peek method. Peek returns the item from the top of the stack, but does not remove it. This is an important distinction between peek and pop. Peek just looks at the new item. Pop removes and looks at the new item. Now, this is a very simple stack class. This is not meant to be a comprehensive example. It's meant to be a simple, straightforward version that we can follow. There'd be more in here. There'd be more error checking in a full stack class. There might be a couple more methods like an isEmpty to tell whether the stack is empty. For now, this is the stack class we have, and we will study it. Here's some code to actually use this stack class, and we'll trace it and see how it works. This first line of code here, underlined, this declares the reference variable, the stack, and calls the constructor method to initialize the object. So it's going to jump from this line of code over to here to run the stack constructor. You can see that I've already allocated the object variable because we've executed new stack. The memory for the stack object is allocated, Into the stack constructor we go. We'll set top equal to -1. -1 indicates the stack is empty. Also be aware of the prefix ++ below that will change this to 0. This -1 is a special value for two reasons. Number one, it tells us whether the stack is empty or not. Number two, the prefix notation will make sure the first item goes into position 0. Notice that max already has a 5 in it. We hard-coded this up into the variable declaration. Again, if that was a parameter to the constructor, we'd be setting it here in the constructor method. Extremely important line of code. STArray equals new int max. Allocate the array now during the constructor. This creates an array object and assigns it the reference variable STArray. Again, max could have been a parameter. If it was to a card game, we'd set that parameter to 52, and this would be an array of 52. Obviously, an array of 52 won't fit on this screen, so I decided to go with the smaller size 5 so we can see how this works. Notice that STArray is a reference to the array object that contains the 5 elements. The array itself is an object. So this constructor is done. It's time to go back to the original call that called the constructor and execute the line below it. In this line of code, we will call the push method. We'll pass 11 as the argument to the parameter item right there. Note, a hard-coded 11 is not a great way to code. More likely, this would be a value stored in a variable like card dealt. When my card game deals a card, I want to make sure that card gets pushed onto the stack, so if I hit the undo button, I can go back and undo the dealing of that card. Let's jump into the push method and see how it works. There's a little trickery going on, so pay close attention to this. Prefix notation. I only underlined this part of the code because this actually gets done first. ++ top executes before the array assignment is done. When the ++ occurs before the variable, it says do +1 first. This is why top can start at -1 and still insert at index 0. So you can see clearly that my top that started at -1 changed to 0 first. After it changes to 0, then I'll do the full array assignment. Then I'll assign item to position 0. So the value of the parameter item, the 11 that was originally passed, which again represents the queen of clubs, is assigned to the array index 0. You can see that top determines 11 goes in position 0 of the array. It's important that you understand that the prefix plus plus top happens before top changes to 0, and then item is assigned to position or index 0 of the array. We'll return the original call to push was finished, so we'll drop down to the next line of code and call push again. Let's call the push method, pass it 22, which may represent the 10 of diamonds, to the parameter item, so item will get the value 22. Again, the hard-coded 22 is not a great idea. Usually it's a variable, the card that was dealt to the user. But intent is clear. We want 22, or the 10 of diamonds, to be pushed on top of the stack. Again, prefix notation. It's very important that you understand that plus plus top executes before the array assignment is done. Top will go to 1. Look at this. Top changes to 1 before the 22 is assigned to the array. Now that top is 1, the 22 will be assigned to the array, and you can see that 22 went into position 1 of the array. And now clearly 22 is the top of the stack. Remember, a stack puts these one on top of each other. 22 is the last item in. It should be the top of the stack. And that's why this variable is called top. At position 1 of the array, you will find the item that is at top of the stack, in this case 22. Returning back to the main code, we drop down to the line after the call to push, and it's another call to push. So let's call the push method, and this time pass it 44. Let's say 44 represents the 6 of spades. To the parameter item, item will get the value 44. Again, hard-coded 44 is not a great idea. Usually it's a variable that contains the last card dealt to the user. Jumping into the push code once again, prefix notation. Plus plus top executes before the array assignment is done. Top will go to 2. Notice how top has changed to 2 before the 44 is assigned. And here's the 44 going into position 2. The value of the parameter item, the 44, is assigned to the array index 2. 44 is now on top of the stack. Pretty simple. The only thing you have to understand here is that plus plus top occurs before the assignment happens. Now that we've seen how to put stuff onto the stack, let's see how to take stuff off the stack. Okay, notice how this line is only covering part of this command. We're going to do the stack.pop first, and then we'll come back and do the card equal. Call the method pop to remove an item from the stack and assign it to the variable card. Let's go into pop and see how it executes. Postfix notation. Notice how this red line only goes partway through. We're not doing the minus minus yet. Top minus minus executes after the array value is returned. The 44 at top index 2 is sent back, and the subtract 1 happens after the value is returned. And of course, 44 is the last in, so we expect it to be the first out. Stacks implement LIFO, or last in, first out. 44 is the last item in. I expect 44 to be the first item out. But again, notice the red line here. It doesn't go all the way through. We're going to do this return first, send it back, and then execute the minus minus. So we assign the 44 returned from pop to the card variable. Then we execute the postfix top minus minus, and we change it to the 1. The 44 is now off the stack, and 22 is the new top. Now this gets a little complicated because of the postfix notation. We are executing the card equal. The 44 that was sent back is assigned to the variable card. After that, the top minus minus executes. Top changes to a 1. And you can see now the top of the stack is now pointing to 22. Well, if the top of the stack is pointing to 22, the 44 is now off the stack. Now, the exact order that this happens is up to the programming language. It's not up to me. Whether this 44 gets assigned a card first and then top is subtracted to 1, or top is subtracted to 1 first and then the 44 is assigned, it's not up to me. Just keep in mind that the value returned will be reflected by the old top variable. When top was 2, we extracted the 44 and sent it back. Then we subtracted 1 from top. Postfix notation says do the minus minus after the command return executes. Returning back to the original calling code, the next line after that, we're going to call the method pop again and remove another item from the stack and assign it to the variable card. Remember your postfix notation. Top minus minus executes after the array value is returned. The 22 at the top, or index 1, is sent back, and then the subtraction of top happens after the 22 is sent back. So let's return the 22 first, assign the 22 to card, then we'll do the top minus minus, and top will go to 0, and the top of the stack is now pointing to index 0, or the 11. So we assign the 22 returned from pop to the card variable. Then we execute the postfix top minus minus, changing to 0. 22 is now off the stack, and 11 is the new top of the stack. Now that postfix notation makes it a little bit more complicated. We could have implemented this in a different way. We could have assigned what was at the top of the stack to a temp variable, then subtracted top, and then returned the temp variable. But then it would take 3 lines of code, or 3 steps to do it. This is a little more compact way to do it. Let's return back and execute the next line of code after that. Now we're going to do just the peek command. This next method, peek, called the peek method. We'll call the peek method and return an item from the stack and assign it to the variable card. The big difference here is we do not remove the item. We return the top of the stack, but we do not remove it. It stays on the stack. So let's see how peek executes. Return stArray of top. Top is at 0. So at index 0 we have 11. We're going to send 11 back to the caller. So send 11 back to the caller. If 11 is at top before the call to peek, 11 will remain the top after the call to peek. Peek that causes no change to the top of the stack. So there's the 11 being returned and assigned to the card variable. The 11, however, is still on top of the stack. Peek does not change the top of the stack. We looked at the top of the stack and got its value, but we did not remove the item from the top of the stack. That is the definition of peek. Tell me what's on top, but do not remove it from the stack. The next line of code is a pop, and we know the pop does change the top of the stack. We'll call the method pop to remove an item from the stack and assign it to the variable card. So for the third time now, we'll execute a pop. Notice the postfix notation. Know where that red line stops. We're going to do our return first and then the minus minus. Top minus minus executes after the array value is returned. The 11 at top index 0 is sent back, and the subtract 1 happens after the 11 is sent back. So we assign the 11 return from pop to the card variable. There's the 11. It just overwrote the previous 11 that peek put in there. Then we execute the postfix top minus minus. We change it to -1. The 11 is now off the stack, and the new top of -1 signals the stack is empty. Nothing left on the stack. We did 3 pushes. We did 3 pops. There should be nothing left on the stack. And the top -1 indicates that the stack is empty. So that top -1 is very, very important. It's the signal that the stack is empty. Remember the prefix notation that we did in push. The next call to push will add 1 to the -1 before it inserts the item into the stack. Therefore, if we call push again, it would go in slot 0 of the array. Now, I'll be honest, there should be a little more error checking in this code. Push should never try and push past the number of items on the stack. Pop should never try to execute if top is already at -1. Peak should not return a value if top is at -1. There should be some error checking in this code. However, as I always say, I have to kind of compress the code a little bit. A, so you can see the essence of the code, and B, so it'll fit on one slide. There it is, a stack implemented with an array.